The threat of an asteroid heading towards Earth is something that scientists at NASA are actively preparing for. They are fine-tuning their plans, knowing that in just a few years, a space rock could make a close pass by our planet. Apis, for example, is one of the most significant asteroids on our radar, and it poses a real risk. This asteroid could cause devastation on a massive scale. The question is, are we ready for such a potential disaster? NASA and space experts are already on it, investigating and formulating strategies. The countdown is underway. NASA has been keeping a close watch on Apis, which is said to pass very close to Earth in the near future. Scientists worldwide are eager to observe this rare celestial event. However, recent data has raised new concerns. NASA has confirmed that they are preparing for a potential asteroid impact, as new calculations suggest there's a 72% chance that an asteroid could hit Earth. In this video, we'll explore why scientists at NASA are suddenly on high alert about a possible asteroid impact and what they're doing to prevent it from becoming a catastrophic event. We need to send a spacecraft to observe Apis weeks, maybe months, before its close approach, said one NASA scientist. Apis, discovered on June 19, 2004, by astronomers Roy A. Tucker, David J. Thalin, and Fabrizio Bernardi, measures about 370 meters in diameter, roughly equivalent to the size of 3.2 football fields. Given its size, a collision with Earth could result in massive destruction. On April 13, 2029, Apis is predicted to come particularly close to Earth. This date is crucial because the asteroid will pass closer to Earth than many of our orbiting satellites. At its closest, Apis will be only about 310,000 kilometers away, roughly 1/10 the distance between Earth and the Moon. This close encounter will be the closest an asteroid of this size has ever been to our planet in recorded history, and it will be visible to the naked eye in certain parts of the world, appearing as a fast-moving point of light. At the moment, Apis is still far from Earth, moving through space in its orbit around the Sun. Its position constantly shifts due to its high velocity and the gravitational pull from other celestial bodies. To track Apis, scientists rely on advanced telescopes and radar technology, ensuring they have precise data on its trajectory. When Apis was first discovered, there were concerns about a possible collision with Earth in 2029. Initial calculations pointed to a slight but real risk. However, after further observations and more refined models, scientists now believe that Apis will not hit Earth in 2029. The risk has been essentially ruled out, but its close approach still offers an excellent opportunity for scientists to study the asteroid up close and learn more about objects like it. Though the risk of impact in 2029 has been largely dismissed, scientists continue to monitor Apis closely. There's still the chance that its path could be altered slightly by Earth's gravitational pull during the 2029 flyby, which could affect future close approaches. The next time Apis will pass close to Earth is April 13, 2036, and it's important to consider whether its trajectory will be influenced by the upcoming encounter. If it is, the 2036 pass could pose a risk to Earth. But the real question is, are we prepared to deal with this kind of threat? If a dangerous asteroid were detected early enough, humanity could theoretically take action to deflect it. NASA recently carried out a hypothetical planetary defense exercise to assess how prepared we are for an asteroid impact. In the scenario, an asteroid that had remained undetected due to its orbit around the Sun was found to be on a collision course with Earth. The asteroid, estimated to be large enough to cause significant regional damage, was predicted to strike in 2038. It was between 60 and 800 meters across, with a 72% chance of impact. However, there was only 6 months left to gather more data, as the asteroid was expected to pass behind the Sun and be unobservable for 7 months. Despite the long warning period, the exercise concluded that humanity is currently ill-equipped to prevent such a disaster. Initial observations weren't enough to determine the asteroid's size, composition, or exact trajectory. The asteroid's position behind the Sun further complicated matters, making it difficult for scientists to track. The exercise highlighted several challenges in planetary defense, especially the limited ability to deflect or disrupt an asteroid with little warning. Technologies like kinetic impactors or nuclear devices would require years of testing and development before they could be viable options. International cooperation is also essential, as the consequences of an asteroid impact would be global. This recent exercise is a wake-up call to the international community, reminding us that while asteroid impacts are rare, they do happen and we need to take proactive steps to ensure the safety of our planet. Earth's most recent encounter with asteroid danger occurred in 2013, when a space rock the size of a 6-story building came unexpectedly close. The Chelyabinsk meteor, about the size of a 6-story building, exploded over Chelyabinsk, Russia, on February 15, 2013. The explosion was more powerful than a nuclear blast, and shock waves from the event caused damage as far away as Antarctica. It shattered glass and injured more than 1,000 people. Some scientists even believe that the meteor was so bright it may have briefly outshone the sun. This event served as a powerful reminder to space agencies about the importance of monitoring smaller objects in space that could pose a threat to Earth. Learning from these incidents, NASA has successfully tracked recent asteroid impacts. A small asteroid that flew over Germany in 2024 was predicted and tracked using NASA's Scout Impact Hazard Assessment System, showing that we can monitor such objects. Although the asteroid, designated 2024 BX1, burned up harmlessly in the atmosphere, the exercise was an important demonstration of NASA's planetary defense capabilities. However, the recent International Planetary Defense exercise also raised concerns about how we would handle a real asteroid crisis. Lindley Johnson, NASA's Planetary Defense Officer Emeritus, stated that one of the key takeaways from the exercise is the need for better data on asteroid size and trajectory to avoid the complications caused by uncertainty. It also highlighted that there is still a great deal of work to be done in terms of global collaboration and preparation for these types of celestial disasters.